This is problem number 5. We've got a fund X where we deposit $1,000 and it earns 6% interest. And we've got a fund Y which earns 9% interest. And at the end of each year, we're going to take $100 as well as the interest that was earned from fund X and deposit it into fund Y and let that accumulate. And then we want to find the accumulated value of fund Y at the end of the 10-year period. So let's have a look at how these payment streams were constructed. We deposit the $1,000. We earn 6% interest, which brings our fund value up to $1,060. But then we withdraw $100 as well as a $60 interest. And we're going to keep those two payment streams separate, leaving ourselves with $900 in fund X. And then again, we earn 6% interest on that $900, which brings the value of the fund X to $954. But at the end of the year, we withdraw $100 again, as well as the $54 that was earned in interest, bringing us down to $800. And the process continues. 6% earned on $800 takes us to $848. Withdraw $100, withdraw the interest, down to $700, and on until there's nothing left in the account. So what we've got here is two payment streams. One of $100, it's just very constant, earning 9% interest, and another that is decreasing by $6 each time period, that is also earning 9% interest. So we've got two annuities here. We want the future value, or the accumulated value, of this constant stream here, and the future value, or the accumulated value, of this decreasing annuity right here as well. So this is the formula, or the equation that we're going to write. 100 times S sub 10 at 9% plus 6 times the decreasing annuity over 10 years at 9%. Let's get a value for the first annuity. Using our formula, we take the accumulation factor, raised to the power of 10, subtract 1, divide by the interest, and get 15.14 or 15.19, thereabouts. Do the same for the decreasing annuity. Over 10 years at 9%. Number of years times the accumulation factor raised to the number of years minus the value of the annuity that we just found divided by 9%, the interest rate. And that comes out to just about 94.26. So now we can substitute these values into our equation and solve. 100 times 15.19 plus 6 times 94.28 is just about $2,084.86. Rounding to the nearest dollar gives us a final answer of C. So when it comes to exam FM, half of the battle or more is this first chunk right here. Creating the timeline and correctly accounting for or correctly representing the different payment streams that we're working with. From there, you can write an equation, and then the actual number crunching really isn't all that challenging. Whether you're using your annuity formulas or you've got your financial calculator here. And then I suppose recalling which formulas to use can be challenging as well. So two things on FM. One, really writing out a good timeline that makes your payment streams clear. And two, recalling the correct formulas to use. Like you've got your annuity due, your annuity immediate, your present value, your future value, your increasing, your decreasing. It's easy for those to get jumbled up in your mind, but the more you practice with them, the more clear they will become. So write a good timeline, work with your formulas until they're easy to recall, and then once you've written your equation, the numbers are going to fall right out.